Welcome back. This is week 2 of 4 for our conference this year. If you missed week 1, which was the Miseducation of CSS by Corey Brown, you can view it here on Vito until the end of October. So don't fret, you have all month to watch all 4 of these talks. In fact, at the end of each one of these talks, you'll have until the end of October to watch them in case you miss one. So, great. Welcome back. So glad to have you all here with us again today. I want to remind you that we have some one-of-a-kind Utah.js merchandise for sale this year. Click on the Utah.js merchandise link on the website where you're viewing this talk and get your hands on some of that sweet, sweet merch. In fact, we have Utah.js face masks, which will probably be hopefully will be a 2020 only merch, which you will never want to or need to buy ever again. All right. This week is sponsored by Workfront. And please join me now in welcoming Workfront. They have a 2-minute video that we're going to watch now before we get on with this week's talk.
The work your company does is more complex, global, and connected than ever. Delivering measurable outcomes at a rapid pace can be a challenge. Workfront can help by orchestrating and executing work across the enterprise, connecting strategy to delivery. Here's how. With Workfront, all your work is in one intuitive place. No matter where your teams are, they can stay connected and collaborate on the right work. Workfront supports different work methodologies, helping your team stay productive with automated workflows and engaged by personalizing the way they work, integrating with tools and systems they already use. So no matter who or where, everyone can collaborate and be productive with the context they need to deliver. As your company evolves, Workfront helps you optimize and scale processes to meet the evolving needs of your business as the market changes. You can plan and prioritize iteratively with real-time insights to help you stay responsive to change. All that data is actionable, helping you make key decisions with visibility across the business. At Workfront, we're committed to your success, leveraging a network of work management experts, verified best practices, and optimization strategies. With Workfront, enterprise work management can help your company, departments, and teams plan, predict, collaborate, evolve, and deliver their best work.
Thanks again, Workfront, for sponsoring this video and this week's talk. Every year, so many great sponsors come out of the woodwork to sponsor this conference, and we literally could not do this without them. So thank you so much. They make this conference possible every single year, and this is no exception. Okay, let's get on to this week's talk. This week, we bring you the second of our 4-talk series. This talk is titled Building Components at Scale. It's by Dennis Wilkins. Dennis was born and bred in Utah and is currently managing a UI team on the recently launched rewrite of Facebook.com. Please join me in welcoming Dennis. And remember, stick around at the end. We will have a Q&A session with Dennis right after this talk is done.
Hi, I'm going to talk about building components at scale for engineering and users. My name is Dennis Wilkins, and I've been an engineer at Facebook for 3 years. And for the first 2.5 years, I was an engineer working on the new Facebook.com. But since the start of the year, I've been managing one of the teams that is building the new website. I'm a self-taught engineer that's had some great mentors along the way. I live in the Mission in San Francisco. I love to rock climb, drink and make coffee, and cook. And this year, my goal is to learn to play the guitar. So why did I decide to speak at Utah.js? I actually grew up in American Fork, Utah, and I started my career at Overstock.com. I've worked for Omniture, Adobe, MX, Anonomy Labs, and Newbie, all in Utah. And I actually spoke at Utah.js Conf in 2015, speaking about the data visualizations in React, which is pretty funny because I'd only been coding in React for 3 weeks. Well, enough about me. I want to talk about what the work we've done at Facebook is. So 2 years ago, we decided we want to rewrite the old Facebook.com into a modern, faster, more relevant website, which we are actually launching right now. We decided to use React, GraphQL, and Relay, all the technologies we developed in-house, to drive this brand new website experience. In order for the rewrite to be successful, we needed to build some components, and they needed to meet some simple requirements. To help those requirements, we realized we needed some new tooling for handling how we styled our components. So we created Stylex. What is Stylex? Stylex is a CSS and JS tool that allows us to solve several issues that arise when you're building components that hundreds of developers will use. And let me explain how it works. Here's a React component that uses Stylex. Here we create the style definitions. And each definition is sort of like a class name, and we call it a namespace. And we apply the namespace styles, and then we pass the namespace back to Stylex, and Stylex will give us the class names to apply. It's pretty simple. One common issue with CSS, though, is composing styles together. Let's take this example. So we have two class names, red and blue, and they set the background color to red and blue. And on this body element, we add the blue class name and the red class name. So what color would the body be? Well, it's blue. This is because it doesn't use the applied order on the class. It uses the specificity defined in your style sheet. So what if your build step stitches together your style sheets? Well, typically what you do in regular CSS is you would make your specificity stronger to get the red. So in this case, we do red.red, and that doubles the specificity of that selector. But in Stylex, you don't have to worry about this. Here we have the same namespaces with the styles, and we just need to apply them in order to Stylex. And Stylex decides which classes to apply. No more specificity wars. We use this composition typically to indicate states. Here's an example where we have an element that has some base styles, and when it's selected, we want the background to be red. And when we apply our base and selected styles together, if that prop is true, it merges the namespace's styles together and returns the correct class names to apply. Another thing that we needed Stylex to handle for us was theming. When we started the new redesign, we knew we wanted to have features like dark mode. So we needed to have theming built in to however we did CSS. Theming already exists in CSS on modern browsers, where you can define a variable at the root, and you can use that variable in other style definitions. And since we like this API, we built it right into Stylex, where you can pass in the variable directly into the style, and Stylex will use it. Pretty simple. And the build script for Stylex can swap out those variables with real values if you need support for older browsers. Another thing we wanted Stylex to do is create atomic CSS. Let me explain what atomic CSS is. So in this example, we have a CSS selector that has 4 distinct attribute value pairs. With atomic CSS, each distinct attribute value would have its own selector, which is reused whenever that value pair is directed. With Stylex, you just define your styles as normal, apply it using Stylex, which will generate your class names, and during our build step, it'll statically create the class names and place them in the code. Using atomic CSS helps us keep our CSS byte size down. With consistent designs in atomic CSS, it grows closer to logarithmic pace, whereas traditional CSS grows more at a linear pace. With our old website, which used more of a traditional CSS approach, loading just the home page would take 413 KB of just CSS. But with Atomic CSS, we can load the entire new website CSS in only 74K. Another thing that Stylex can do for us is style expansion. Let me explain. Here's an example of padding. It's padding shorthand. During our build script, it'll actually expand the shorthand into the longhand version. This helps with merging when merging styles that are more complex, where one might be shorthand and the other one might be an individual attribute. Another thing that it can help us with is it can help us with accessibility. Here we have an inaccessible font size of 16 pixels. With expansion rules, we actually convert all static font sizes to rems, which allows the font size to grow based upon the font size settings of the browser. Without doing any work, when the user changes the font size in their browser, all of our fonts will automatically change with it. This helps people who are hard of seeing be able to adjust their font size without having to zoom the page. Stylex also has built-in type checks. Here's a good example of how Stylex type safety can help prevent errors. In font weight, you can pass in numbers or a string, but only specific values for each. Here we have 500, but 501 is not a proper value, so you'll see the TypeScript error here. And on bold, it's valid, but super bold is not. You can put your mouse over it, and it will tell you the error. Another one of my favorite things that you can do with this is you can actually prevent values that you know globally you do not want acceptable. So with z-index, we only allow certain values. That way we don't end up with a z-index war with people putting large numbers, limiting the value to 0, 1, or -1. Escape hatches are component APIs that allow engineers to circumvent or change the standard flows on a per-usage basis without copying or deviating from the original API. So basically, in components, a common thing to do is to change the style of a component. What you'll normally see is a class name attribute added to a component, and this will allow the developer to pass in class names that overwrite the styles to however they see fit. But we decided no more class names, because you can modify styles to large or unwanted values. You can even add unwanted attributes that you don't want them to be able to access. So that can affect things like layering. So if they set z-indexes or positions when you don't want them to be able to change that, these can cause all sorts of problems. So we created xstyle. This escape hatch allows us to type what attributes we want them to be able to overwrite in CSS. So in this example, we're allowing them to overwrite just the padding. And then when they pass in the xstyle, it'll merge the attributes together. You can even be more strict and say, hey, we only want the padding to be able to be one of these values with the typing. So what else did we do beyond Stylex to make components work well for our teams? Well, we needed them to be performant. So we went over atomic CSS, but another thing we needed to do is make sure that we had single pass renders. And this also allowed us to have our components be SSR compatible. We developed our APIs to be code splitting by default. So instead of passing in the contents of a dialog, you instead pass in a reference to where the dialog's contents are, and then we can lazy load them as needed. And we also provided tooling that allows us to monitor the size of our JavaScript, either at the route level, a library level, or however we see fit. Another thing that's common in components is worrying about responsiveness. So responsiveness typically looks like this. You have a desktop display and you have a mobile display. But sometimes it's a little more complicated, where it might be a desktop display, but it has a new sidebar that it's an editor, which shrinks the overall main content. This means we need to be responsive to the container and not just the content. So here's an example. This is a responsive column system, and in its layout effect, what we're doing is we're getting the content element and we're asking the width of it. And with that information, we can determine how many columns to render. But the problem with that is that if the columns resize or the user resizes the window, we end up with old data. So what we can do is we can use a resize observer. But there's another issue with this. This still requires us to do another render when the resize observer finally mounts and determines what size the component it is, then giving us back the new width, which makes it so it's not SSR compatible. So what we end up doing is something a little bit like this. Now here's a simple example using the Fab4 technique, which you can read about on freecodecamp.org. And what we do is some CSS math. So normally this looks like this, and this is just a column. The column is providing the breakpoint and the max amount of columns we want to show when it's above that breakpoint, and when it's below that breakpoint, what the columns it should be. So let me transpose the numbers back over on the component so we can see what that does. So first, now we have a calc of 100% divided by 4, which is 25%. And then on max width, we have 100% divided by 2, which is 50%. So in this example, if our container is 800 pixels wide and our breakpoint is 640 pixels, we're going to need 4 columns. That means on the min width, it actually is 200 pixels. The max width is 400 pixels. So if we do that math, the 640 pixel breakpoint minus our 800 pixel container means we are negative 160 pixels. We're going to times it by a large number, which gives us negative 1.5 million. So which is closer, 200 pixels or 400 pixels to negative 1.5 million? It's 200 pixels. So that gives us 4 columns because we can fit 4 200 pixel columns in 800 pixels. Now another example is if the container is smaller, so 500 pixels. So the min width is 125 pixels. The max width is 250 pixels. We do some math. So that means 640 pixel breakpoint minus 500 pixel container is 140 pixels. Then we times it by 9,999 and we get 1.4 million. So because 1.4 million is closer to our 250 pixels, 250 pixels is used. So that means because we were smaller than our breakpoint, we're only going to be showing 2 columns. This is an example of those responsive columns in use. We have the same breakpoint of 640 pixels. When it's below that, we want to use 2 columns, and when it's larger than that, we want to use 4 columns. And you can see as I resize this, as the container grows, the items stay responsive to it, and the number of columns change from 2 to 4 and then back to 2. Another thing very important for any component system is to have built-in accessibility. One thing we do have is accessibility type checks. So a very simple example is in an image, you may require an alt tag. Pretty simple in the typing, we just make sure it's not optional. But we also need some runtime checks. What if in this props, someone passed in an empty string? So in development mode, we make sure the alt tag is not empty and we throw an error. But in most cases, accessibility isn't this simple. So we created a thing called redblock. Now this runtime check happens after the page is loaded in development mode, and it highlights any accessibility errors we see. And if you put your mouse over it, it'll tell you the violation. So in this example, it says these buttons must have discernible text, and it'll tell you exactly how to fix it. When you're building a large component set, you'll end up finding out areas that you did things wrong. So you need to be able to have a process for deprecating components as you build replacements for them. So we have a pretty simple step-by-step guide for deprecating our components. First, you need to build a replacement component if possible. In some cases, the component that you build will not be replaced at all. We update the documentation on the old component to say it's been deprecated, and we have instructions how to manually upgrade it to the new component. We write lint rules to point to that documentation, so if anyone uses that component or is editing a file with that component, it reminds them that they need to update that component. We also write and execute code mods that will try to go and update the code anywhere that we can automatically. And then we also name the old file so it's obviously deprecated. So the most difficult part about this is writing a code mod. But writing code mods in React isn't really that difficult, and I'll show you an example of a common code mod. So in here we have an icon button. It takes an icon prop, a label prop, and an onClick handler. What we want to convert the icon button to is this button. Let's say we added to the button the ability for it to take an icon itself, and we added a new prop called hide label to hide the text next to it. So we can both show just the icon by itself or the icon with the label text next to it. All right, so I'm here on astexplorer.net. What we want to do is we want to go to transform and say that we're writing a JS code shift transform. We're going to set the parser we want. So normally you do TypeScript. My example is actually going to be using Flow. It doesn't really matter because there's some small nuance changes in how it generates the nodes, but for the most part, the basics are the exact same. So let me paste in our code example. So this is your code that you want to have transformed. So an example, this is your transformer. This is your output that the transformer would do. And then this is what the parser is converting into the AST. So if you click right here, it's saying, hey, look, this icon button is a JSX identifier, that the whole element is an opening element that self-closes. What I want to do here is I'm going to change a little bit of this code to just say this is the source. In the source, we want to find. And at the very end, we want to return source.source. So I'm gonna delete this, and you'll see I have the console open over here. And the reason why I do this is because it's useful to console whatever the transform is doing to help debug it. I'm gonna paste in some helper functions here that help us handle some common tasks. And what these do is they like find and import the name of the import. It'll look for the import. You can add and remove imports. And these examples aren't like what we actually use. What you'd want to use is a package. A good open source one is JS CodeShift add imports for adding imports. There's other ones for removing. There's actually a JS CodeShift team that has a bunch of open source packages you can look for. I want to find the name of icon button, how it's being used. In this case, it's the same name, and that's how you normally want it in your code. But just in case someone named it some different, we're going to do icon button name equals find import default name. I can console.log icon button name. You'll see here it's like, oh, cool, it's the icon button. But if I was importing it and calling it X, you'll see that it's called X over here in the console. What we want to do is we want to find the opening element. All these names right here, the types, you can actually just copy and paste the name. So like right here, we have a JSX identifier. I want the opening element, so I'm going to paste that. If I go and do a find, it'll find all of those. If I console.log the path, cool. You can see over here, the value is the element. Another thing you do with find is you can actually pass in like search parameters. So an open element has a name, and a name is an JSX identifier. So if you see this, we have our open element, and it's got a name, which is an identifier. And in the name, it's got a name called icon button. So you can do a quick filter in here, just do name, and we're gonna do icon button name, the name that we have. So normally in here, when we have our path and we're doing modifications to it, there's a couple ways to do it. What we normally do is we use Babel types to, which the package to do like Babel types dot clone deep path dot value. So new path equals this, and then this allows us to modify that, but it's a copy of it. And then when we have decided we successfully have transformed this to however we want, then we replace it. But in this example, I'll just modify the stuff directly in line since we can't import Babel types here. In this example, let's say all icon buttons that we have need to turn into a button. But let's say icon button itself by default always has a shadow. But in button, we need to explicitly pass in shadow equals true. So what we want to do is our shadow attribute. We need to create a JSX attribute. And how do we know that what that looks like? Right here, label. Okay, that's an identifier. That takes in a JSX attribute, and the attributes belong to your opening element. Great. Before we use the j.jsx opening element to do a find, and we match the case exactly to the type in the AST. But this time we want to create an AST node by the type. So what you do is you start with a lowercase letter, and in this case we do j.jsx attribute with the JSX lowercase. Okay, and then it takes in, you'll see here, a name, and that happens to be a JSX identifier. So you want to do j.jsx identifier, and then we're calling that shadow, and then we want to pass in the value is true. Now I'm going to write something here that doesn't work. So this is a JSX literal. The problem with this is that if you look at like when you write code, you don't write, shadow equals true, because that's not valid. You have to do true. So what does that look like? Oh, it's an expression container that holds a literal. So that just happens to be something that you have to learn. And this is why it's really useful to like be able to have this example and have this build out what it looks like. So I want to do j.jsx expression container. And then now I have a shadow attribute. And then here, what I can do is I can take the attributes and do path.value.attributes.push shadow attribute. And now everything here has shadow equals true. What we want to do is we also want to change the name of this, right? So we have path.value.name, so we're changing the name, and then the name's name, because the name is an identifier, and we can just call it button. All right, so now they're all buttons. Let's just make a little flag, has transform equals true. We want to remove our import. Okay, now it's not in here anymore because we've successfully transformed it once. Add import. So when you add import with this thing just takes whatever the path is. Obviously, the relative path will be different. This is why you want to use a helper function you give it the full path, and it will find where this file is based upon. Now the import for the replace component is done. That's all we need to do for this basic code mod, converting our icon button to use button. And we know that our code mod will generate valid JavaScript, whereas if we used a regex, we probably would have spent more time writing the regex and would have less confidence that we'd end up with valid JavaScript at the end. With any component library, you want to make sure with whatever you write that it can live for several years. A lot of us have written a drop-down.js. And if you look online, there are tons of packages for building drop-downs all over the React ecosystem. And even in our own code base, we found out that there were several drop-down.js implementations. The problem with this is that you end up with inconsistent experiences between drop-downs. You end up with inconsistent styling. You have performance problems because you end up downloading the JavaScript for the different drop-downs. And then occasionally we had accessibility issues where in certain drop-downs, not all the accessibility requirements were implemented. So we decided to create a component platform. Think of it as a separation of the interactions from the styles. That way in the future, if we need to, we can always swap a different style on top of it and still maintain the same platform. So an example here is we have a base component that handles buttons. And at Facebook, we have some pretty complex buttons. So in our base button, we handle all the complex interactions, but we also take an X style. And in this case, our X style has to provide whether it's hovering or not. So X style actually is a function that will return X styles. And then in our implementation of our button that all the individual developers use, it just handles determining which styles need to be applied. So in this case, we determine what theme we're using and what style we should have when we're hovering. And we just forward that on to the base button. So the benefit of doing this with all of our components is that it allows us to share this with other design systems like internal tools, Ads Manager, and Facebook.com. We have consistent experiences between those. It allows us to do design experimentation on Facebook.com. So in the future, if we decide to change the design, we can, and we can experiment with it. Accessibility is built directly into this platform, so every design system automatically gets it. And we end up with component hardening. So over the life of these components, we know they've been well tested. And finally, I want to leave you with a few rules of thumb that we learned along the way to make it more easy to develop and use our components. The first thing is we try to be obvious. One way that we do this is that we have no higher order components. With hooks, we don't need to do higher order components. No clone element, because that can make it less obvious why elements have changed. We believe naming is very important. That accessibility is not optional. That right now you may think you don't need to do accessibility stuff, but you never know in the future when that can change. Deprecation should happen early to prevent people from using deprecated components and having to make more cleanup work for yourself. Create examples for each prop where you can, because not everyone likes reading documentation and would rather read code. And write good documentation, because not everybody likes reading code for their documentation. And finally, thank you, Utah.js, for allowing me to talk about components today.
Thank you, Dennis, for that incredible talk. It was fantastic. I learned a ton of stuff watching that. It's just amazing to me how far the web has come and all these tools that have been developed from so long ago. We have now a few questions that we'd like to ask you from some folks who have seen the talk. So let's go for it.
Cool.
The first question is asking about the accessibility tool that you shared in your talk that highlights accessibility issues. And the question is that available to the public or just internal to Facebook?
Right now, it's only available to Facebook. I'm not sure what the plans are. I know the team is building a bunch of equality tools related that are very generic, but I'm not sure if they're planning on releasing that.
Okay. And the second question is kind of in that same theme, but referring to the responsive column component that you showed in the talk, is there an open source link to that?
There isn't, but all the math and the information for it is available on Free Code Camp. It's a technique that they actually created for emailers that actually really works for doing responsive stuff in just container-based stuff.
Cool. All right, the third question is, can Stylex be used with any JavaScript front-end framework, or can it only be used with React?
So all it really provides for us is that merging capability along with creating the class name. So I don't see why it couldn't be used in any other JavaScript library, since what you get back is a string of merged class names.
Cool. I was trying to think of a joke there of like trying to think of the oldest JavaScript library I could think of to
Yeah,
integrate with it. Like maybe
probably work
Mootools.
with Backbone. I could see it
Yeah.
working with Backbone.
Yeah. Cool. All right. Nice. That was an endorsement there from Dennis, just so you know. All right. What feedback? Oh, sorry. Okay. Next question is, what feedback has your team received from developers who have used these new components and this new, well, they say component library, but the whole technique, I think, the whole suite.
Yeah, so that's a good question. So I actually created like surveys that we sent out to engineers on a half basis to try to like solicit that feedback, try to get an overall sentiment. That way we knew we were going the right direction, and a lot of like information that we would get in the like commenting section was also really nice for gathering feedback. One thing we did notice is that naming, I talked about naming being very important. It's still like very difficult no matter how much time you spend naming things to get naming right, and that actually like caused some issues within our tooling, whereas people were naming things similar to our stuff and wondering, people are wondering, hey, is that part of your library or is it part of the component set? And that caused some issues. We also, we typical issues where like APIs weren't as flexible as engineers wanted them to be, and loosening that up slowly but carefully. We had general things like that. I guess we had a lot of refactors and a lot of code mods we had to run when we decided, hey, we have engineers coming to us saying this API is what we would expect it to be or what we want it to be, and a lot of times we're in agreement with it. because we want to make sure that like we get adoption as much as possible versus people creating their own components. And because that's how one of the ways that we measure our success is whether we get good adoption of the components that we write. And yeah, so we had to write code mods, occasionally to change things. Like that icon button to button example is an actual example. The code wasn't the actual code, but we did simplify things and just allow you to pass icons directly to the button, because then eventually users were like, do I want it on the left? Do I want it on the right? How do we handle this stuff? How can we automatically do accessibility, like switching it for RTL languages and that kind of stuff?
Cool. Super cool. I think a lot of people who don't work at large companies underestimate the effort that it takes to get adoption of new ways of doing things, Like
Yeah.
it's very much like a persuasive exercise. And I
Yep.
actually remember, I did an interview with Pete Hunt, I don't know, like 6 or 7 years ago. That was his name, right? One of the creators of React, I think is his name, Pete. Anyway, and he was just talking about how we didn't force anyone to use React. We just said, look, if it's good, it'll get adopted, and obviously it has. But
Yeah,
very interesting.
that even the rewrite of the website was, we had to convince product teams to want to put their site stuff on there because it does cost them, engineering hours. It's
Right.
really interesting.
Yeah, it is very interesting. Just I wanted to double click on one thing you said. Um, oh, I lost my train of thought. Shoot. Sorry.
No worries.
Uh, okay, we're gonna just let that one go. That it was gonna be amazing though. I just want you to know that.
I believe it.
Okay, good. Okay, let's maybe it'll come back to me later. Let's move on to the next question here. So, the other question was, have other teams adopted Stylex within Facebook?
Yeah, so we actually saw about, 8 months into using Stylex as our experimental replacement for the website or whatever you want to call it, before it was like solidified that what we had built could actually work for what our needs were, which were being performance and responsive and all that. Um, we had we had like talked with the other components team for ads manager, and now ads manager is a completely different organization from Facebook's website. And so they're the ones that like use React more than actual Facebook.com did. And they were continuing to use the same CSS stuff that we had previously used, along with some other like additional tooling, but nothing like targeting like a lot of the issues that we had addressed in our consumer side. And maybe it was because they didn't have the direct need of it, but they ended up adopting it. They got a lot of the value that we got. There were some issues where you're adopting two CSS stuff. You have old code, you have new code, where you end up with having to download the JavaScript and the CSS to handle our stuff, but also the CSS that their stuff had to handle. So there was two competing systems, but in the end, they ended up using it, and we actually ended up getting messages for Stylex, because Stylex is actually built by the components team, not like an infra team. Normally, we do have UI infra teams that build like React, right? Because we have React
Mhm.
as a team. And Stylex was actually built by our components team because it was a need, like an actual thing that we like addressed really early on in the process. And you know, we even like put like, we named it something underscore like do not use in big caps, and we ended up getting pinged by people across the company, be like, this thing's awesome, can we use it on our internal tools, can we use it on this or that? And at first we were really hesitant because we didn't know, like, we didn't want to support something if in the end our project didn't succeed, right? But eventually, like, Stylex got so much critical mass that itself would live beyond that project if it didn't succeed, and we ended up like letting pretty much everybody uses it now. I can't code without it. Can't code styles without it pretty much at this
Yeah.
point, because it's like so ingrained with how we do styling. I don't know. I think it's a great API too.
Yeah, I agree. It seems really cool. And I remember when the first day that the new Facebook site came out, the first thing I did was pull up the inspector, and I'm like, what the heck is all this stuff? All those Stylex identifiers.
Yep.
And I was like, and now I know. Now I know. So thanks for pulling back the curtain on that. Okay, I remembered what I was going to ask you previously. And in the last question, we were talking about the feedback that you received from developers about the new stuff. And one of the things you called out was that you had some pushback or some concerns about the naming enforcement. And I was wondering if you could go into a little bit more detail about the nature of that, because naming is one of those things that's very hard to enforce and also very hard to get right. So it's like the perfect combination of problems where you would want some kind of automated enforcement, but it's just like not able to provide that. Can you describe like what the concerns are about naming things, and how did you actually enforce naming? And lastly, like um, do you just lead by example here? Or do you have like documentation and guidelines on how to name things right, or what's the whole story there?
Yeah, so one thing we learned really quickly on building the new website is that being noisy to developers really like through lint rules or flow errors or stuff like that, that's the easiest way to get their attention, especially if they do something wrong and it's just like in their face and they can't really suppress it. And if you do suppress it, we throw another warning saying, hey, we saw you suppress something, you probably shouldn't be doing this, please. And like we basically got rid of all warnings too. We made everything like an error, right? Effectively on the linter. Um, so the issues we had with naming, we actually applied and created lint rules that we decided that we're going to take over a certain namespace. So we had like a code name for our redesign, and our components were like code name, then that. So, like code name select, code name button, right? So, but then we would have people redoing the website for their stuff, and they would call it like code name marketplace button. And people would load it up, and the marketplace engineers, they have enough engineers, they would see these things, or even and people would be like, hey, why can't I use that button? I like that API better. And like, well, that's a product team's button, like the ownership's different, right? If you use that, we make no guarantees. You can see there's like no examples, there's no documentation. It's up to you. So we ended up like with one case that like this is the easiest one that we could lint for, is we just made it so the product name had to go before the code name. So that way they could still identify this is the code for the new website, but also it's part of this product. And then effectively we scoped everything to certain folders saying like, if you're not in this folder and your file starts with this name or your component starts with this name, we're going to throw lint errors at you. And I mean, one thing that we got really good at was like writing and reading the AST. So it really helped with code mods, and it really helped with like really complex lint rules that we ended up building. There was other things like where we'd have like row, list, item, selector, cell, right? Like you're like those names were really long, and we worked on like reducing the names of that. And that also helped reduce friction, but that was more on our team, just making sure that we had a good naming in place, and we didn't like write lint rules for that specifically.
Got it. Cool. Thanks for that. Next question is, what challenges have come up since the redesign with your components? You had a chance here to start from scratch. You've launched now, and I'm curious what challenges have come up since then.
Yeah. So, I mean, there's been a ton of challenges, anywhere from like we we initially were following to the T a design system that was developed by designers for mobile and for web. And so we wanted to make sure we had like almost exact pixel for pixel parity on designs, even down to the props, like where even though they weren't using React, they take, attributes that go in and create a component on iOS or Android. And so when a designer would describe that as the body text, we would make sure our props were the body text, right? Like the prop actually said body text on it. That way, if a designer created a component and they described each individual area that could be modified in the component from a design perspective, everyone had the same API, and that the limitations of what you can do are limited to just what they had described, and internally we do everything else, right, through like magic or whatever. Um,
Through magic or whatever. That's my
yeah,
favorite.
exactly. I mean, sometimes it is magic. Like if we think about like from a complexity standpoint, how complex some of these really got, like, yeah. So that seems all beautiful and well, except then you hit a point where you're like, web isn't mobile. Like that, the mobile requires you to do X and Y, and you might be 2 or 3 clicks to get something. And in web, that's going to destroy your funnel, right? Like increasing the amount of clicks. On mobile, it doesn't necessarily, because there's really no other way. You're limited by space and size, and people are just like accustomed to having to tap a few times, right? Um, and so we ended up having these problems where we actually needed to redesign our components in a way that we deviated from the design system, which also made it so that we had to rewrite these components, and there was no like clear way to actually code mod it from A to B because the APIs were so different, because the actual usage was so different. And that required like a lot of work because we were, a year into the project, and we have 20 plus engineers that have already developed entire pages using these all over the place, to the point where there's like 100 different uses of certain components, and 100's a lot, especially if you don't have any context, because you only built the component, you didn't actually build those surfaces. So that was probably the biggest challenge, is whenever we ran into those problems where things we couldn't code mod. And occasionally we would code mod something, think we did a great job at code modding it. It looked really well. And then it'd be like some place where someone was doing something kind of funky, like wrapping it in like some weird flexbox thing, expecting like forcing it to do something odd through how they were handling the component to like do something that we didn't want them to do. And then it would break their like view completely, right? So I don't know. And another thing is like, when you have like all those different variants in a certain component, like with these components rule and wall, you start modifying some of the styling, and then there might be 300 other variants of that component through, just like we changed the color style, and we changed some padding, and we changed like whether we have a left item or right item or center item or a headline item. And the next few things broke. So we had to write an entire like screenshotting testing framework for everything. And that was a pretty cool project that I was on. And that saved us a lot of time once we had that implemented.
Cool, thanks. So this next question harkens back a little bit to the question we asked earlier about what kind of feedback you got from various developers who were using this. But I want to highlight just one portion of that kind of feedback and get your input on this. So most of the techniques that you described, if not all of them, in some way or another tie the hands of developers, where they say you can't do this, you can't do that. You have to do it this way, and we're not going to support other ways. Did you get pushback from developers who felt like they were being too constrained?
Yeah, I mean, all the time. The thing is, it's a lot easier to go from constrained to slightly more loosened up and find the right balance than it is to go from really loose and strict, like make everything's a little more strict. Because a lot of times when you do that, you have to go, you don't just modify your own code, you're going to go modify everybody else's code that now violates this new rule. And again, you don't have the context, you don't know what the right solution is all the time because you didn't write that code. So yeah, I mean, that happened all the time. And the thing is, a lot of it, we try to like think of, like Stylex is a good example. If we try to think of how the developers actually develop, are they always going to be perfect at determining the best way to write styles, right? Are they going to remember to use rems all the time? Are they going to remember to do this or that? And so a lot of it is like, if we lead them into a tool that we know they can use and that provides a lot of value, that we can like show them, then at least within that system we can convert things back to font from font size down to rem if they forgot to do that. We can do all the RTL stuff automatically because we know that things are left, and now we had to apply it to the right because we flipped the page, and we're doing things automatically like that. So by using our tooling, we gave them free accessibility in a lot of places and a lot of things, and then they in turn were like, you know what, this is a good trade-off for us. And occasionally we did have to loosen things up.
Makes sense. Cool. So you had the benefit of implementing all of these constraints and tools within effectively a new code base, although I'm sure that's not entirely true, but you were starting from scratch on a greenfield project. How much more effort would you say it is to adopt these techniques on an existing code base without starting from scratch?
Yeah, I mean, it depends on the technique. Certain techniques, it's like very difficult. I think, and like I said, like with accessibility, it's like really difficult after the fact to go in and make things accessible. In my opinion, it's just a lot of work. It's a lot of like actual hours invested in doing work that's could have been slowly trickled throughout the process, right? Now, like moving over to Stylex, like and doing that, not too difficult. You can technically code mod CSS back to Stylex. Like if you haven't, like CSS is readable by an AST, and you can actually generate the stuff that you need out of that, and uh, it's possible to like basically get like 95% of your code converted to it in after spending maybe a day writing some mappings and then running it. Um, I think let's see what else. There's a bunch of let's see what else other things that we did. Responsiveness. Yeah, you can just piecemeal that in. I think a lot of this stuff, like components, especially like the base component abstractions. We started that pretty early on, but occasionally someone would write a component and write no abstraction on top of it because their only end user at the beginning of these base components was us. And so, like, if we just wrote a consumer version of it without a base one, no one would notice sometimes, right? And so we'd have to go back later. And then once we did that, then we had like ads manager coming in. They would like notice, hey, we noticed that component's not fully like design like agnostic here. So can you fix it? But I think you can do that like piecemeal pretty easily. It just takes time.
Yeah, cool. Uh, Next question is how conducive are these techniques to unit testing?
Yeah, so I think a lot of the component related work is very testable. What one thing we did find though is that we didn't find a lot of value in writing anything but end-to-end tests. Like we got a lot of noise from unit tests, and because we're components, for the most part, we're just doing visual things, right? And so an end-to-end test, how does this thing render, is important. And one thing that we wanted to make sure for good adoption is that we had really good documentation, but we also wanted to have really good examples. So we had like an examples file for every component, and it would export like an array of examples, ways to use it. But that was also really valuable. Once we built that screenshotting service, we literally just would ingest the examples and walk through them and paint them on every single theme that we had. So dark mode, light mode, across multiple screen sizes, and auto snapshot every single one of them. So you would have an example file with, let's say, like 30 variations. We would actually end up with 60 times, so 300 different screenshots generated. And the engineer did nothing. They basically went and did, I'm going to do an example. I'm going to, show people how this component works. And boom, we had good tests for those to make sure that if a pixel moved on accident because they were tweaking something, that they would know.
Nice. Fantastic. So lighter on the unit tests and heavier on the end-to-end testing. Very interesting
Like
approach.
the unit tests, the only unit tests we ever really wrote were for lint rules and like code mods. So
Huh.
like almost
Interesting.
exclusively end to end, because in the end, like the infra like is so complex that like testing one little piece is nice, but like testing does it all work together was actually a lot more valuable to us.
Yeah, that makes sense. Very interesting. Going to cause some waves with that one, I think.
Oh yeah.
Um, so this
And the
is
company did too. So
Yeah. So this question is a little bit specific and kind of esoteric, but I'm not super familiar with code mods, and I suspect a lot of folks just don't use code mods on the regular. But I wanted to understand just conceptually when you decide to apply a code mod. Um, so of course you're traversing the AST, which is the abstract syntax tree of the code. It's a representation of your code. It's not the actual text that you save in your file, and you're making modifications to that tree. But at some point, that has to be written out again. So my question is, does this happen at runtime, or does it happen at build time? And if it's at build time, do these mods actually get rewritten out as files and checked back into source control, or is it all just magically happening at build time behind the scenes?
that's a good question. Yeah, code mod usually gets ran just once. So you run it and then you commit it like as a post-run version of this code mod. Now, there are certain things that we ended up like putting into like Babel, like as a Babel transform, which is effectively like a code mod, right? We're taking one thing and converting it to something that works in multiple browsers, and that's like our Stylex, how we code mod actually out the attributes and stuff and just replace it with the hash version, so there's no calculation done when you're in production. Um, yeah, but these components, the code mods, like we definitely we one thing that we do is we commit them. A lot of people make the mistake of they've written a code mod, they apply it to their code base, and then they throw it away because it's kind of like a one-time use. But the problem with that is then you don't get to learn. Like if you have a similar code mod, imagine just copying, pasting it, and modifying it a couple things and changing it, and saving that and then running it. So we actually make sure that we commit our code mods and then we apply them. And then also we can say this is the link to the code mod that was reviewed by other people, and that's how it got into the source code. And then people can, evolve those code mods over time.
I could imagine a scenario where you want to rerun a code mod because some developer, maybe you wrote a code mod to move some legacy code to some new approach, but then later some developer uses the legacy approach again, and you want to like clean that up with another code mod run. Do you ever get into a habit of just rerunning them to see if they find anything?
Yeah, I mean, occasionally, like sometimes it's almost like we know that we hit 80% of the code, that we need a code mod safely, and so we'll just write the code mod so it only affects those, and then that gets rid of all the most of those usages of it. Then we might have like isolated another 12% or 15% that's going to take us twice as long, 10 times as long to write, but we know that those teams aren't going to manually go move those, but we can code mod it, so we'll extend upon it again. Usually we don't have the issue of the deprecated like things that we've decided to code mod out being used, just because like if you use a deprecated component, it like yells at you. Like if you get into a file that uses deprecated components, even if you didn't even touch those lines of code, it's going to be like, hey, you need to go and migrate this, right?
Yeah,
So
you can't even touch this.
yeah, exactly. So and I mean, it seems kind of like restrictive, and sometimes, I mean, you can get approvals from people in your diffs to say no, but yeah, like I don't want to like migrate this right now. It's out of the scope of this diff. But yeah, it helps. Yeah, so the code mod, the lint rules definitely help with preventing people not using the deprecated or whatever
Right.
components.
Got it. Cool. Well, this has been just super informative for me, and I really appreciate you kind of, I don't want to say pulling back the curtain because, nothing you shared is proprietary or whatever, but I really appreciate you sharing these insights and things you've learned. I sense that I kind of have this sense that we're moving as an industry from a less constrained environment to a more constrained environment, which of course brings with it pain, but also unlocks a whole bunch of new functionality like you've been describing, which is just really cool, and really appreciate you sharing all that with us. If people want to get in touch with you, what's the best way?
I probably just Twitter, which is funny because I work on Facebook, but yeah, get it.
Okay.
You can touch me there. So
All right.
cool.
This has been Dennis Wilkins from Facebook talking about how to basically build one of the world's largest component systems. So really appreciate your time, and thanks so much for the information.
Yeah, thank you.